And then we got P1 minus P2 squared C squared plus 2 squared P1C plus P2C Alright, so we've just gotten rid of our MC squared. And then squaring this guy out, and we can immediately see we can get rid of our C squareds. Oops. Sorry, this is equal. Sorry. So that was the left-hand side or right-hand side. We got rid of the MC squares. We can cancel out the C squareds. And we're left with P1 squared plus P2 squared minus 2 P1 P2 plus 2MC P1 minus P2 P squared. All right. Cool, cool, cool. We'll call this equation, we'll label this equation star. Label this last equation star. We'll use in a moment, Alright, so we got all this from energy conservation. Let's look at what happens when we consider momentum conservation. Okay. Momentum conservation. We've got that P1 is equal to P2 plus the momentum of the electron. Right, so this was before, and this is after the collision. Or we've got that PE was equal to P1 minus P2. Okay. And doing the dot product, we're squaring both sides. We've got that square of our momentum, right? Is equal to P1 squared minus 2 P1 P2 cos theta, right? Just doing the dot product plus P2 squared. All right. Very good. Okay, and we'll label this equation double star. All right. If we combine both equations then, single starred equation and double star, we've got that P1 plus P2 squared minus 2 P1 P2 plus 2 MC P1 minus P2 is equal to P1 squared plus P2 squared minus 2 P1 P2 cos theta. Okay. All right. And of course, we can see we can kill off a few terms, right? I can get rid of my P1 plus P2, those two squared. All right. And now notice every term has a 2 in it, right? The surviving terms have 2's in them. So we'll cancel those off as well. So I'm left with minus P1, P2. MC P1 minus P2 is equal to minus P1 P2 cos theta. All right, and we're almost there. Right. So moving this term over to the right-hand side, we've got then that MC P1 minus P2 is equal to P1 P2 times 1 minus cos theta. All right, good enough. Good enough. The last few steps and then we're done. Multiplying each side by a common term. Alright, so MCP1 P2 is in the denominator. Right, we get this. H MCP1 P2 times each side of our previous equation. MC P1 minus P2 is equal to P1 P2 1 minus cos theta. Or add H over P2 minus H over P1 is equal to H over MC 1 minus cos theta. Very good. All right. Then we can rewrite this using our quantum. And finally, we've got lambda 2 minus lambda 1 is equal to H over MC 1 minus cos theta. All right. And we're done. And we're done. Very good, very good. Okay. Any questions? Come see me in office hours. All right, y'all.